All right, we're here to talk about the normal distribution. I believe there's 6 videos in this series. Before we start talking about the normal distribution, I want to talk about an application of the normal distribution uh, that's has to do with grading. A lot of professors say that they grade on a curve, and I'll show you what that actually means compared to, and it might differ a little bit in terms of how it's actually practiced. So what does grading on a curve mean? Most people take that to mean that it's easier to get an A. That it would mean more A's, but we'll see that that's probably actually not the case. Does it mean easier grading? Well, kind of. It means that it's easier grading in terms of a raw percentage that you might have to get for an A, but we'll see that that percentage itself is not something that is that's going to be the same across different courses. So it's often used to mean increasing grades relative to an average score, and that's actually a kind of a misuse of it. Grading on a curve actually, when it's done in the formal way, could actually make it harder to get a good grade. One application you might see here, if the average score for the class was 70%, the A might end up being 85% instead of 90%. Yeah, that's making it easier to get an A in that context, but we'll see what it means to get an A when we're actually grading on what's called a curve. And one thing we'll see is that maybe this isn't necessarily good for students. So when we're grading on a curve, we're not talking about what instructors often talk about when they say they just lower the scale based on class average. That's not actually grading on a curve. Grading on a curve means using certain properties of the distribution of scores that you have to make decisions about where the cutoff should be, rather than using an arbitrary value like 90%. So, and the values that we're going to be using is the mean and how far we are from the mean in terms of units of standard deviation. So we're going to be using those two things we learned about in the next section together, both the mean and the standard deviation. So a typical grading curve for a class that had a mean of 70% and a standard deviation of 10%, the C would be set at plus or minus half of a standard deviation from the mean. And when I say half of a standard deviation, that means half of whatever our standard deviation is. So that would be on the lower end a 65, on the upper end a 75. Now again, that might sound good to you because you're used to hearing you need 70% for an A, but if the for a C, but if the class mean is actually 70%, we're going to see that that means something different than if you were in a class where the mean was 85% or something. The C ranges here from 65 to 75. We can see with the B, half a standard deviation all the way up to 1.5 standard deviations. So that's going to be a score of 75 and to a score of 85. So 75 to 85. Again, in terms of raw numbers, that might look like it's good for students because you only need a 75% for a B. But those percentages are really meaningless unless we take them in the context of both the mean and the standard deviation. And A would be anything above 1.5 standard deviation, so you'd need an 85 or higher for the A. And then on the bottom end, a D would be negative, D would be half a standard deviation below to 1.5 standard deviations below, so 55 to 65, and then an F would be 1.5 standard deviations below and more. So that would be 55 and below. What does this mean in terms of the likelihood of getting each of these grades? Well, actually, we know that getting an 85% or higher when we're talking about units of standard deviation, get about 7% of the class. And we'll demonstrate how we get that in a little bit. A B, that's going to end up covering about 24% of the class or a quarter of the class. And I think at this point, you're recognizing, wow, this maybe isn't the best thing for the class because less than a third are getting A's and B's, which probably is not your experience in most courses. A C would be 38%. And then where this starts to get interesting is we see that for every B, we're going to end up having a D grade. Keep in mind when people used to grade on a curve like this, a D was still considered to be a passing grade. And an F, well, for every A, there's got to be an F. So if we're talking about a class of 100 people, about 7 people will get an A, 7 people will fail. The majority of people will get a C. All right, so where do these numbers come from? They come from something called the standard normal distribution. Now think about how rarely you hear both of those terms used in the same phrase, standard and normal. So this should imply that this is something that's extremely common, something that we're going to see a lot. And we'll see statistically, this is really a product of nature. It's something that we see naturally occurring. It's a natural distribution of numbers, and it has some properties that allow us to draw some conclusions. You may have heard of this before as the bell curve, specific distribution following a bell-shaped curve. And it's probably by far the most important distribution for statistics. We see that this becomes the basis of a lot of the stuff we do, especially when we get to what's called statistical inference, when we're using inferential statistics rather than just descriptive statistics. This is going to be kind of the heart of a lot of the conclusions we're able to draw. Just a few pictures to show you what the curve looks like to round out this section. You can see it can be broken into different areas. Roughly 68% of the distribution is within one standard deviation of the mean, 95% within two, more than 99% within 3 standard deviations. So we see that being really far from the mean in terms of standard deviations is relatively rare, much more likely to be close to the mean. And we also see this in terms of various distributions. I just grabbed some variables from various papers that I'm working on. This is a distribution of scores on a scale called the Pro-Black scale, and you see that those comprise very much that normal-looking shape that we saw. Here is maximum weekly temperature. This is from a study I did a few years back looking at temperature and hate crimes. See that the maximum weekly temperature does follow that normal shape. I think this was maximum weekly temperature like in, it's probably Los Angeles area. So you can see that follows a normal type curve. Similarly, your body temperature follows a normal curve. We say 98.6 is the average temperature, but people actually show a range of temperatures, with some people hitting 100 as their normal temperature. All right, so the main topics we're going to cover in these slides are going to be the standard normal distribution, what we call z-scores or standardized scores. We'll see that this is a formula that takes scores from any distribution and it puts them on a scale where we can directly compare across different distributions. This is called standardizing the score, and the reason why it's called standardizing the score is because we're taking how far the mean the individual score is from the standard deviation and dividing it by a standard deviation. So it is basically in units of standard deviation. And we'll talk also about areas under the normal curve, what we can do with this knowledge of how scores tend to be distributed. Like when I said, 95% of the scores are about 2 standard deviations from the mean. Well, we can actually use those values along with our z-scores to draw some conclusions about how many people we might find in specific groups. All right, I'll stop here and we'll move on to the next slide after you're